Now next is arithmetic series. Up to this we learn about sequence. That is arithmetic sequence. Now we learned about arithmetic series. The series corresponding to an AP is called an arithmetic series. The nth term of the arithmetic series, that is AP series, corresponding to AP is, that is AP sequence A plus D, A plus 2D up to so on, nth term A plus n minus 1D. Therefore, Sn is equal to sum of n terms, that is A plus D, so on A plus n minus 1D. That gives n by 2, 2A plus n minus 1D, the general formula of sum of n terms. That will be proved by principle of mathematical induction, that is stated by theorem 3rd of this chapter. So we will prove this theorem or this result by principle of mathematical induction in the next lecture. Now we are going to state and prove theorem 3rd. If the first term of an AP is A and D is the common difference, then the sum of first n terms is Sn is equal to n by 2, 2a plus n minus 1d for all n belongs to n. Now we'll prove this theorem by principle of mathematical induction. Now we see, first of all, let statement P and B Sn is equal to n by 2, 2a plus n minus 1d for all n belong to n. Now we will prove for the first part, that is for n is equal to 1. P of 1 is 1 by 2, 2a, that is a. That is the first term S1. Therefore result is 2 for n is equal to 1. Now let us pause. Result is 2 for n is equal to k. Therefore, P of k, that is S of k, is equal to k by 2, 2a plus k minus 1d for all k belongs to n. So result is 2 for n is equal to k. Now we have to prove Result is true for n is equal to k plus 1. That is, we have to prove S of k plus 1 is equal to k plus 1 over 2, 2a plus k plus 1 minus 1 d for all k belongs to n. As we know that S of k plus 1 minus sk is equal to k plus 1 term. That is, S of k plus 1 is equal to sk plus t of k plus 1 term of the sequence. So sk is true as, so we put the value of sk, that is k by 2, 2a plus k minus 1d, and k term is a plus n minus 1, that is k plus 1 minus 1d. So we get 1 by 2 outside and we get 2ak plus k square d minus kd. And by taking the LCM here, plus 2a plus 2kd. 1 and minus 1 is cancelled out. So here we get half 2ak plus k square d plus kd, that is minus kd plus 2kd, kd plus 2a. So we get half of 2a is common out from these two terms and we get k plus 1, and from these two terms we get k is common, d is common, in the bracket we get k plus 1. So all over k plus 1 is common out over 2 in the term 2a plus kd. Now kd can be rewritten as, that is k plus 1 over 2, 2a plus k plus 1 minus 1 d. So if we see n is k plus 1, it becomes n by 2, 2a plus n minus 1d for all n is equal to k plus 1 and k belongs to n. Therefore, we get same Sn term for the required expression. Therefore, as pk implies, pk plus 1 is true. Therefore, by principle of mathematical induction, result is true for all n belongs to n. That is, Pn is true for all n belongs to n. That is, for sum of n terms is given by of AP sequence as Sn is equal to n by 2 into 2a plus n minus 1d, or we can rewrite as n by 2 a plus n minus 1d. So if we see, this is the Tn term. If there are n terms, then Tn term will be last term and we denote last term by L. So it becomes a plus L. So this is the other expression of sum of n terms. Therefore, sum of n terms is n by 2 a plus L when a and L both are known. So these are two expressions to find sum of n terms of an AP. Now we will do some problems which are based on AP series. So the problem is, find the sum of first 15 terms of an AP, that is 15, 11, that is decreasing series. Numbers are decreasing. So here we have to find out sum of 15 terms. Therefore n is equal to 15, a is equal to 15, d is equal to 11 minus 15, that is minus 4. Always remember T2 minus T1, not T1 minus T2. So Sn is equal to n by 2, 2a plus n minus 1d becomes 15 by 2, 2 into 15 plus 15 minus 1 into d, that is minus 4. So we get 15 by 2, 30, minus 14 into 4 is 56. So we get 15 by 2 into minus 26, that is 15 into minus 13. That gives minus 195. Therefore, sum of first 15 terms is minus 195. Now the next problem is the sum of first n terms of two APs are in the ratio 3n plus 6 ratio 5n minus 13 for all n belong to n. Find the ratio of their 11 terms. Now we have to find the ratio of 11 terms of two given series. Now the solution is, let the first term of 1 APB A1 and common difference is D1. Now let the first term of second APB A2 and D2. Now according to given condition, we have S1 first series n terms and ratio of second series n terms is equal to 3n plus 6 over 5n minus 13. So sum of first series is n1 by 2. So number of terms are same, so we will denote by n. It will not be differentiated. N by 2, 2a1 plus n minus 1 d1 over n by 2, 2a2 plus n minus 1 d2, that is 3n plus 6 over 5n minus 13. That gives n by 2 is cancelled out and we get 2a1 plus n minus 1 d1 and 2a2 plus n minus 1 d2, which is equal to 3n plus 6 over 5n minus 13. Now we have to make Ratios of these two 11 terms of two series. If we see here, we have 2a1. 11 term is a plus a1 plus 10d. We have to make here 10d1. So we have to take 2 common. If we put n is equal to 21, we will get 20d1. So 2a1 plus 20d1 becomes 2 times a plus 10d1. That is the 11 term. So such type of question can be solved by this method. We have to assume what will the double of that term and we will get this. Double of 10 is 20. So we have to get 20. So we have to put here and that is 21. So put n is equal to 21 in above ratio. We get 2a1 plus 20d1 over 2a2 plus 20d2 is equal to 3 into 21 plus 6 over 5 into 21 minus 13. So we get 2 is common out from the both. So we get a1 plus 10d1 over a2 plus 10d2 is equal to 21 into 3 is 63 plus 6 and here 105 minus 13. That gives T11 over T-11 which is equal to 69 over 92. On 23 it will cut out 23 3s are 69 and 23 4 are 92. So we get ratio to 11 terms of 2 APs is 3 by 4. This was all about the arithmetic series.